Researchers at ETH Zurich have demonstrated the use of a specially coated metal mesh to harvest water from fog and simultaneously remove pollutants. People living in dry but foggy areas should benefit from this technology. In countries such as Peru, Bolivia, and Chile, it is not uncommon for people who live in foggy areas to hang up nets to catch droplets of water. The same is true of Morocco and Oman. These droplets then trickle down the mesh and are collected to provide water for drinking, cooking, and washing. As much as several hundred liters of water can be harvested daily using a fog net only a few square meters in area. For regions with little rain or spring water, but where fog is a common occurrence, this can be a blessing. One crucial drawback with this method, however, is atmospheric pollution, since the hazardous substances also end up in the droplets of water. In many of the world's major cities, the air is so polluted that any water harvested from fog isn't clean enough to be used untreated either for drinking or for cooking. Researchers at ETH Zurich have now developed a method that collects water from fog and simultaneously purifies it. This uses a closed mesh lattice of metal wire coated with a mixture of specially selected polymers and titanium dioxide. The polymers ensure that droplets of water collect efficiently on the mesh and then trickle down as quickly as possible into a container before they can be blown off by the wind. The titanium dioxide acts as a chemical catalyst, breaking down the molecules of many of the organic pollutants contained in the droplets to render them harmless. The researcher says that their system not only harvests fog but also treats the harvested water, meaning it can be used in areas with atmospheric pollution, such as densely populated urban centers. Once installed, the technology needs little or no maintenance. Moreover, no energy is required apart from a small but regular dose of UV to regenerate the catalyst. Half an hour of sunlight is enough to reactivate the titanium oxide for a further 24 hours, thanks to a property known as photocatalytic memory. Following reactivation with UV, the catalyst also remains active for a lengthy period in the dark. With periods of sunlight often rare in areas prone to fog, this is a very useful quality. The new fog collector was tested in the lab and in a small pilot plant in Zurich. Researchers were able to collect 8% of the water in artificially created fog and break down 94% of the organic compounds that had been added to it. Among the added pollutants were extremely fine diesel droplets and the chemical bisphenol A, a hormonally active agent. In addition to harvesting drinking water from fog, this technology could also be used to recover water used in the cooling towers.